I remember in my last video, I was discussing about a question tested in 2009, August 2009. And I was just writing the question before I had issues of network. So I said, Utensils Limited deals in productions. It deals with production of cups and bowls. It deals with production of cup and bowls. And we say the production require the labor. The labor input as follows. They require labor inputs as follows. So we are being given the cups. Then you have your bowls here. Right? So we start with machine hours per unit. So machine hours per unit here, you're given 4 for cups and 2 for bowls. Then the labor hours per unit. The labor hours per unit, here we require 3 and also here 2. So the available machine hours, and labor hours. Available machine hours and labor hours are 100,000 and 80,000 respectively. Required here, we are being required using matrix algebra. Using a matrix algebra, we've been taught to use a matrix algebra method. Right? We have been told find the optimal number of cups and bowls that should be produced by Utensils Limited. Very simple. We have been told using the matrix algebra to determine how many cups and bowls are they supposed to be produced by Utensils Limited. Now, let us start by formulating, because already you can see you're being given the maximum hours that we have for machine hours and labor hours to produce these cups and bowls. The first thing that you have to be coming up with is you formulate 2 equations. For example, let me start with machine hours. I will say I will take 4C. Remember, it's 4 for cups. So C represents cups plus 2 bowls, where 2 represents, where the B represents the bowls, is equal to the maximum hours given for machine hours, which is 100,000. Now the other one will be 3C plus 2B is equals to 80,000. I want to get the values of C and B, but now I want to use Cramer's method. I just want to use Cramer's method. And Cramer's method is just a method of replacement. It is just a method of replacement. Now, in this case, we just need to be formulating our equations. Let's first come up with a matrix form of our equation. So we just take the values 4, we have 2 here, right? 4, 2, and then we have 3, 2. Then we take the unknowns, which is C and B, which should be equal to 100,000 and 80,000. So when you look on the calculation of C, when you look on the calculation of C, it means I'm going to be taking these values on my right-hand side to replace the first column in my matrix. Now, in this case, it will be looking like this. It will be looking like this. So it will be, to get the value of C, I just take 100,000 and 80,000. Then I copy paste the second column, which is 2 and 2, right? Then you divide by the original matrix, which is 4, 2, 3, 2. Then we calculate the determinants. We say to get the determinant for any matrix, we're going to be taking the product of the primary diagonal, right? Which is 200,000 minus the product of the secondary diagonal, which is 160,000. So this is equivalent to 40,000. When I look on the matrix on the downside here, the primary diagonal is 8, right? 8 minus 6, and this is 2. So it means to get the value of C now, I just need to take 40,000 divided by 2, which is 20,000. Which is 20,000. Which is 20,000. If I want to get the value of B, I do the same. So to get for B, you replace the second column. It will be 4, 3, right? I copy paste the first column, and because I'm looking for the second value, which is B, I copy paste the second column, which is 100,000 with the right hand values, 100,000 and 80,000. Then also you divide by the original matrix.
Excuse me, Mwalimu.
Yes.
Okay, after writing C is equal to 100, okay, after doing that in NA, I can see D is equal to 200,000.
This is the value for determinant. This is a determinant. Your determinant for the upper matrix is 40K.
Okay.
The lower, the denominator, the matrix, the determinant there can be 2. So what is the value of C? You divide the both determinants. 40,000 divided by 2, you get 20. Now, when you do your calculations here, you'll find that my determinant on the lower, on the lower denominator, we have said the determinant is 2. Now, on the upper, I take the product of the second diagonal, which is 320,000. Minus we take the product of the second diagonal, which is 300,000, right? Here getting 20,000. Then it means the value for B, you just need to take 20,000, you divide by 2, getting 10,000. Even if you do using the long method, that is what you're going to be getting. But I normally see these being the simpler method to calculate both determinants for 2 by 2, not determinants, but to solve any question using the Cramer's method, whether it is 2 by 2 or 3 by 3 matrix. Now, I just want to proceed to look for last semester's the April question. Let me look here for April for QA. They brought a question of here. You can read question 4A.
Limited produces 3 products, namely A, B, and C. The company presents the profit per unit of the products it produces and sells as follows: fillings 2,000, 3,000, 4,000 for product A, B, and C, respectively, during the month of January 2022. Shillings 7,000, 9,000, and 4,000 for product A, B, and C, respectively, during the month of February 2022. Shillings 1,000, 4,000, and 2,000 for product A, B, and C, respectively, during the month of March 2002. The total profit in the month of January, February, and March 2022 are shillings 17 million, 45 million, and 16 million, respectively. Required: the total number of each product produced and sold using matrix algebra.
Now, when you look on that question, the examiner has already given you the profits which are basically reported during the respective months. We have the month of January, February, March, and also he has given you the profit per unit given there. But the examiner is asking for the total number of each product being sold, and it is the product values will be represented by the values for these products will be represented by the letters given, whether it is A, B, and C. So in this case, we are going to be reducing our question to thousands for easy calculation. For instance, let me go to my board so that I can be able to show you how to solve these kind of questions. So when I look at it here, the examiner was able to tell you that there is two. But now, because I just want to formulate my equations, the first equation, we are being given the profit generated for January, and we are being given 2,000, 3,000, and 4,000. If I reduce to 1,000, it means we are going to be writing 2 of A, because it is 2 of product A, plus it is 3B, then plus 4C. It should be equal to the profit, the total profit which was generated in January, which is 17,000 now. Now, I just want to formulate the second equation. We have been told in the month of February, right, the company was able to generate 7 of A profits, plus the other one is 9 of B, plus the other one given it is 4 of C, which is equals to the profit generated during the month of February total was 45,000. Now, when I look on the third and the last equation, we have been told we were able to generate 1,000 of A profit. Then it means it is A plus, we have 4,000, which is 4B, plus the other one we have been given there is 2C, which is equals to 16,000. I just want to write this in matrix form, right? Then it means I have to be taking the values and then I leave unknowns. So it will be 2, 3, 4, 7, 9, 4, 1, 4, and 2, right? Then my unknowns is A, B, and C, which should be equal to 17,000, 45,000, and then we have 16,000. Let us use Cramer's rule to solve 3 by 3 matrix. Now let us start with A. To get the value of A in this scenario, to get the value of A, I think you can be able to see my board. So to get the values of A, sorry? Can you see the board?
Yes, I can see
now, just take these values, replace the first column. So it will be 17,000, 45,000, then we have 16,000. Then you compare the second and the third columns. So it is 394. Then we have 442, right? Then you divide by the original matrix. Our original matrix here, we have 2, 3, 4, right? 7, 9, 4, and then we have 1, 4, 2. We said to calculate the determinant for the 3 by 3 matrix, Just copy paste the first two columns. So here it will be 17,003, 45,000, 9. Then we have 16,004. Then here we are going to be copy pasting 2, 3, 7, 9, and 1, 4. So here I just want to get the product of the primary diagonal. And in this case, I'm going to be taking these values. Right? So it will be 17,000 times 9 times 2 plus 3 times 4 times 16,000 plus 4 times 45,000, right, times 4. I'm going to be getting my value there. Then the product of the second diagonal, which is this one, right, which is that one. It will be 16,000 times 9 times 4 plus 4 times 4 times 17,000 plus 2 times 45,000 times 3 times 3. And give me the answers. So the first one, when I look on the first one, is 17,000 times 9 times 2 plus 3 times 4 times 16,000 plus 4 times 4, 4 times 4,500, 45,000, sorry, times 4. I'm getting 18,000. The second one will be 16,000 times 36 plus 16 times 17,000, right? Plus 6 times 45,000. I'm getting 11,118,000. So to get this determinant here, for the upper value, I'm going to be taking 18,000 minus 11,118,000. So 18,000 minus my answer, I'll be able to get 100,000. Now, let me look for the determinant for the lower matrix. So here, you do the same. The product of the primary diagonal. So it is this one. It should not be like that. It should be like this. Now it will be 2 times 9 times 2 plus 3 times 4 times 1 plus 4 times 7 times 4. Then PSD, it is these ones. So we have 1 times 9 times 4 plus 4 times 4 times 2, right? Plus 2 times 7 times 3. Now we have 18 times 2, 36, plus 12, plus 28 times 4. We are getting 144 here. Then the second, for the secondary diagonal elements, we have 36, plus 16 times 2, 32, plus 6 times 7, 42. Getting 110. Subtract. How much are we getting here? 144 minus answer, I get 34.
34.
Yes. Now to get the value of A, I just need to take 100,000, right? I divide by 34. So 100,000 divided by my answer here, I'm getting 2941. And this should be units. 2941 units. 2941 units. Now let us go and calculate for B. Let us do for B. Let us do for B now. And we do the same. Now to calculate for B, I'm going to be replacing the second column in our chart here, in our matrix, sorry. So it will be 271. We have 17,000, 45,000, and then we have 16,000. Then we replace the third column, 442. We copy paste, sorry. Then you divide by the original matrix. 2, 7, 1, 3, 9, 4, 4, 4, 2. We said here the determinant is 34. That is how easy it is. I'm not going to be calculating it again. But now let me copy paste the first and second column in my numerator matrix. So 217,000, 7, 45,000, 1, 16,000. Now, let me take the product of the primary diagonals. So it will be PPD is equals to 2 times 45,000 times 2 plus 17,000 times 4 times 1 plus 4 times 7 times 16,000. Then we have PSD, where I'm going to be taking my PSD like this. Right? This is 1 times 45,000 times 4 plus 16,000 times 4 times 2, then plus we have 2 times 7 times 17,000. Right? So how much is this? So 45,000 times 4 plus 16,000 times 16 plus 14 times 17,000. I'm getting 674,000. On the upper side, right, it will be 2 times 45,000 times 2 plus 17,000 times 4 plus 28 times 16,000, getting 696,000. So to get the determinant here, we are going to be taking 696,000 minus 674,000. Okay, minus 674,000. We are getting 22,000. So to get the value for B now, I'm going to be taking 22,000, which is the upper determinant, and then we have the numerator determinant, which is 34. So 22,000 divided by 34, you are getting 647 units. 647 units. Let me do for the third one and the last value or unknown. Now, I just need to replace the third column. The third column now. The third column, we have 271. We have 3, 9, and 4. We have 17,000, 45,000, 16,000, right? Then we replace the first and second column. So we have 2, 3. We copy paste, 7, 9, 1, 4. So PPD of mine, it will be looking like this. So it is 2 times 9 times 16,000 plus 3 times 45,000 times 1, right? Plus 17,000 times 7 times 4. Then we have PSD, which is equals to, you can see here. So it is 1 times 9 times 17,000 plus 4 times 45,000 times 2 plus 16,000 times 7 times 3. So let me start the first one, 18 times 16,000. 18 times 16,000 plus 12 times 45,000 plus 28 times 17,000. This I'm getting 1304.
So
The other one will be 17,000, very good, times 9 plus 8 times 45,000 plus 16,000 times 21. I'm getting 849,000. To get the determinant here, I'm going to be taking 1304,000 minus 849,000. So 1304,000 minus 849,000. 445. 455, sorry.
455,000.
Very good. So to get the value of C, we just need to take 455,000. You divide by 34. Divide here by 34. And I'm getting 13,382 units. 382 units. That is how you normally solve your problems using matrix algebra. And also you apply the Cramer's rule in that manner. Now, I just want to do another subtopic here, right? Another subtopic, which is very much targeted by the examiner. Just need to also to do 2 illustrations. And then later on, I finish with input-output matrices. Now, the matrix is just that wide. Then when we finish it, then the next time we shall be meeting, we do probabilities. Now, when I look on the Markov analysis, right? When I look on the Markov analysis, it is a new term in which sometimes we might not be finding it familiar in our curriculum, but the Markov is just a probabilistic and stochastic system. Is a probabilistic and stochastic, stochastic system, right? That is used, probabilistic and stochastic system that is used to predict the future state. By use of initial states vector, by use of the initial state vector under transition probability matrix. Under transition probability matrix. That is what we discuss about the Markov analysis. So it means you are going to be predicting the future state. And it means we have to be using probabilities, right? And also the transition probability matrices. Now, we have to be using the initial state vector. If you are predicting the future, and this is what we normally do our budgets, you look on the current situation the company is facing, or how is the company faring right now, then we use probabilities. We might be incorporating certain proportions for which are going to be factoring inflation and so on. So to get the next period here, we normally take the initial state vector, then you multiply by the transition probability matrix. That is what we are discussing about the next period. You're going to be taking the initial state vector, you multiply by your transition probability matrices. Now, when you look on it, we normally look on this technique on how it is normally designed, and we say the technique is normally designed. The technique is designed, right, to predict the behavior of the system. To predict the behavior of the system. To predict the behavior of the system of events. The behavior of events over a period of time. So there are terms which are basically used here. And the first term, we are going to be discussing about what it is stochastic or probabilistic process. Now, when you look on the stochastic or probabilistic process, we are saying it normally arises wherever there is a series of events which are determined by a chance. Arises whenever there is a series of events which are determined by a chance. So it means this is something that we are going to be looking at, the probabilistic processes. It means that there is a series of events which are taking place and are going to be determined by a chance. That is one. Now, number two, we look on the transition probability matrix. Transition probability matrix. And when I look on the transition probability matrix, I say, it is just a matrix that contains, the probability or process, moving from one certain state in the current period to another state in future, Now, number three, I will be able, it is not mostly used, but because I'm just looking on the terms which are basically applicable much in our calculations, the others will be able to see them and their definitions in the notes which I will be able to share. The other one, it will be number three, which is mostly used. We normally look on the steady equilibrium state. Stroke, sometimes it might be the long run state, or we call it vector. And in this case, we say it is a state where Markov analysis ceases to predict. The Markov analysis ceases to predict. So it means that when you are predicting use Markov during that state, it will be predicting and giving you the same solutions. So it is just a state where the Markov analysis will be able to see, or it ceases to predict. To calculate this kind of questions, because these are the three main terms which are used in the questions to solve any Markov analysis question, what we are supposed to be looking at, it is two questions. I will be able to give you the two questions. Let me work for you the two questions right now. The first question that we're going to be starting with, the first question, it will be on September 2015. It should be question 1B. The assumptions for Markov analysis will be included in your notes. Now, let us look for this question. Quantitative analysis here. Question number 1B. You can read, please.
The research industry has three market research firms, namely X, Y, and Z, which provide research services. The following data has been collected in relation to the flow of clients among the three firms. Number of clients, market share, X, Y, and Z. The data is provided. Required. Convert the above data into a matrix of transition probabilities. 2. Estimate each firm's market share for 2015.
When I look on this question, the examiner has already given you a chart where we have the gain from and we have the losses too. And we are being given the number of clients at the end of 2013. Then it means they are the opening in the month of 2014. Then we are being given the closing balances for the year 2014. You can see them there. And then it means that my market share will be in decimal places. It means it is just a form of probabilities. Now, when I look on that question, I will be able to think of filling or concentrating my attention to the losses too, so that I can be in a position, or you are in a position to predict the next period. Now, in this scenario, we are working with the losses too. The losses too, you can be able to see them there. So we are being told to estimate the next 2015, the market shares. So to convert this information to the matrix of transition probabilities, let us first work with the losses too, because the organization normally looks on how they are going to be improving from their weaknesses. Now, from that aspect, this is what we normally do. The first thing is to fill those gaps, right? So the table for the losses too, it looks like this. The losses too. So let me look for the table. So it looks like we have the losses too. So the losses too given, we have X, Y, and Z. X, Y, and Z. And then we were being given dash. The examiner was able to give you dash 30. And then we have 18. Then the other one, it would be, right? The other one will be 24 dash, 24 dash, we have 14. Then the third one, it will be 40, 10, and dash. So let us look on the opening balances, which are the closing for the year 2013. So the closings, they are the one to determine the number of clients we have during the current year. The examiner has already given you that data. We have 402. Then 402. We are being given 408. Right? We have 832. And then we have 1062. So let us fill our data or our gaps. Now, the first one, you take 408 minus 48, row-wise. 408 minus 48. And here you're going to be getting 360. The second one, it will be 832 minus 38, 794. Then the other one, it will be 1062 minus 50, and you are getting 1012. Now, if you can add these values row-wise, if you can add them column-wise, sorry, you are going to be getting the balance given by examiner for 2014. So we have 360 plus 40 plus 24, getting 424. The second one is 794 plus 40, getting 834. Then the last one, right? The last one will be 1012 plus 32, getting 1044. I just want to show you that when you do like that, then it means your data that you have gotten is correct. Now, let us get the matrix of transition probabilities. Matrix of transition probabilities. Now, in this case, let us get the matrix by dividing with our opening balances. So the first one, it will be 360 divided by 408. The second one will be 30 divided by 408. The third one will be 18 divided by 408. The other one will be 24 divided by 832. 794 divided by 832. Then the other one is 14 divided by 832. The last one, it will be 40 divided by 1062. 10 divided by 1062. Then the last one is will be 12 divided by 1062. Your probabilities, you know very well, they are supposed to be coming to 1. So let me start with the first one. 360 divided by 408. You are getting 0.88. The second one will be 30 divided by 408. I'm getting 0.07. Then the last one should be 18 divided by 408. I'm getting 0.04. 0.04. Is it totaling to 1? Let me check. 0.88 plus 0.07 plus 0.04 is equivalent to 1. Then the second one will be 24 divided by 832, getting 0.03. The second one will be 794 divided by 832, getting 0.95. Then the last one, it will be 14 divided by 832, and I'm getting 0.02.
0.02.
Straight away getting 1. The last one will be 40 divided by 1062. I'm getting 0.04. Then we have 10 divided by 1062. I'm getting how much? 0.01. Then we have 1012 divided by 1062. I'm getting 0.95. Getting also 1. That is what we discuss about the matrix of transition probabilities. Now, the examiner wants you to get the estimates for the market share for 2015. Then it means we have to be using the balance sheet at the end of year 2014. That is the initial state that we are in right now. So in this case, we say to predict the next period, you use initial state vector, you multiply by the transition probability matrix. Very good. Now, in this scenario, our initial state vector is given in the question. It is given here. So in this case, this is how you normally arrange your matrix. This is how you arrange your matrices. So it will be, the examiner has already given you 424, right? The other one given for Y, it will be 834. And then the other values given is 1044. This one you multiply by the transition probability matrix, 0.88, 0.03, 0.04, 0.07, 0.95, 0.01. Then the last one is 0.04, 0.02. Then we have 0.95. Sorry. Now, in this case, to predict the next period, you take the rows and columns. Rows and columns. So to get for X, for instance, because this is X, this is Y, this is Z. So to get for X, you take your row, you multiply it with your column. So it will be 424 times 0.88 plus 834 times 0.03 plus 1044 times 0.04. Then you get for Y, it will be 424 times 0.07 plus 834 times 0.95 plus 1044 times 0.01. Then we go to Z, and it is 424 times 0.04 plus 834 times 0.02 plus 1044 times 0.95. So 424 times 0.88 plus 834 times 0.03 plus 1044 times 0.04. Here you are getting 439.9. The second one will be 424 times 0.07 plus 834 times 0.95 plus 1044 times 0.01. 832.42. Then the last one, it will be 424 times 0.04 plus 834 times 0.02 plus 1044 times 0.95. Getting 1025.44. Now, let us get the total summations here. The total summation, it will be plus 832.42 plus 439.9. You're supposed to be getting 2297.76. Now, you can get your market shares here. Let us get our market shares. So I take 439 and divide by the total, 439.9 divided by my answer here. And I'm going to be getting 0.1914. The second one will be 832.42. I divide by 2297.76. Getting 0.3623. Then the last one, it will be 1025.44. You divide by 2297.76. You're getting 0.4463. That is how you get the market shares. That is how you get the market shares. That is how you get the market shares for the respective periods. Now, I just want to look on another question, 2018. There is another question there for 2018, and you give me 1 minute, please.
Okay.
Can you read the question? Read the question.
Question.
1B. It is on our screen right now.
1B or 2B?
2B, sorry.
X Limited, Y Limited, and Z Limited deal in the production of detergents. On 1st January 2017, the three companies introduced a similar new detergent in the market. Prior to introduction of the new detergent, the three companies had an equal share of the market. A survey conducted on the market share of the three companies as at 31st December 2017 reveals the following. 1. X Limited had retained 90% of its customers but had lost 3% and 7% of its customers to Y Limited and Z Limited respectively. 2. Y Limited had retained 75% of its customers but had lost 10% and 15% of its customers to Y Limited and Z Limited respectively. 3, Z Limited had retained 80% of its customers, but had lost 5% and 15% of its customers to X Limited and Y Limited respectively. 4, there were no significant changes in the buying habits of the customers during the year. Required: 1, the market share of the 3 companies as at 31st December 2018. 2, the long run market shares of the 3 companies.
Very good. Now, to get the market shares for 2018, remember the examiner has given us a data on January 2017, and we have been told that the companies are supposed to share the market, and we are being given some data there. Before you go to those additional information, because the additional information given, they are the ones that are going to be determining the next period, because they are transition probability matrices. They are the ones that are going to be predicting the future state. Now, in this scenario, the first thing that we have to be doing is to determine the market shares at the beginning of 2017. So this is what we do. This is what we have to do. Because we are calculating the market shares for 2017, what we are supposed to be doing, right? The market share is equal at the beginning of the period. So we are discussing about first 2017. The market share is equal. How? You take 1/3, you are getting 0.33. Let me put 3 decimal places. So because we want it to be 1, I just say for X, it will be 0.333. For Y, 0.333. Then for Z, we take 0.334. Because that probability should be equal to 1. When I look on the transition probability matrix, the transition probability matrix, this is what I am supposed to be doing. We have our X, Y, and Z. And we are being given additional information there, right? Additional information given. It is going to be assisting us to get all these information, or to get this transition probability, because you are going to be stating, let me just state here 2, and here we talk about from. It will be assisting you to get the probabilities easily. Now, when I look on additional information 1, X Limited are retained 90% from, so X Limited was able to retain 90%, that is 0.9, right? And then we are being told of the customers, but has lost 3% and 7% to Y and Z. So we have lost, there's some customers of equivalent to 3% have moved to Y, and then the other one, 0.07, have shifted to Z. Let us go to additional 2. Y Limited has retained 75%. Y has retained 75%. You put here 0.75, right? 0.75 of its customers, but has lost 10% and 15% to X. And so here it is 0.1. And then the other one we are being given is 15, right? Is it 15? 0.1, 10%, 0.15, 0.15. It looks like that. Then when you go to Z, which is additional number 3, Z Limited has retained 80%, 0.80, right? 0.80 of the customers, but has lost 5% and 15% to X and Z, to X and Y. So it means 5% for X, 0.05. Then the other one is 0.15. 0.15. This is my transition probability matrix. Now, to get the next period, we said use the initial states. Use the initial state vector, you multiply by the transition probability matrix. The transition probability matrix. Now, remember your market shares at the beginning of the period. Our initial state is that one. So in this case, I just need to say the initial state it will be because we want to get for the end of the year to predict for 2018. So I just say, let us get for the end of the year, 31st December 2017. That is the next period. Now, in this case, I'm going to be using the data that I have, 0.33, 0.333, 0.334. This one I multiply by our transition probability matrix, 0.90, right? 0.10, 0.05, 0.03, 0.75, then we have 0.15. The other one is 0.07, 0.15, then the last one is 0.80. Now, to get for X now, because the X, you know, it is represent the first column, it will be 0.333 times 0.90 plus 0.333 times 0.10, right? Plus 0.334 times 0.05. Times 0.05, we are going to be getting that one. Are you there?
Yes.
So you're going to be getting that one. Then we go to Y, where it is 0.333 times 0.03 plus 0.333 times 0.75 plus 0.334 times 0.15. Then to get for Z, 0.333 times 0.07 plus 0.333 times 0.15 plus 0.334 times 0.80. Then we look on how much we are getting there again. So in this case, I start with the first one, right? Which is 0.333 times 0.90 plus 0.333 times 0.1 plus 0.334 times 0.05. Here we are getting 0.3497. The second one will be 0.333 times 0.03 plus 0.333 times 0.75 plus 0.34 times 0.15. We get 0.3098. Then the last one, it will be 0.333 times 0.07 plus 0.333 times 0.15 plus 0.334 times 0.80. Yeah, we are getting 0.3405. Those are the openings for the year. Those are the openings for the year 2018. Those are the openings for the year 2018. So to get for the next period, because the examiner, these are the openings now, because they are the closing for 2017, then it means they are the opening for 2018. And because the examiner wants us to get for the 31st, 2018, right? We do the same thing. Because now we have the initial states, which is 0.3497, 0.3098, 0.3405, right? This one we multiply with our transition probability matrices. Let me write it here. So it will be 0.3497, right? 0.3098, 0.3405. Then we multiply by 0.90, 0.10, 0.05, 0.03, 0.75, 0.15, 0.07, 0.15, 0.80. So to get for X at the end of the year, 2018, we take 0.3497 times 0.90 plus 0.3098 times 0.10 plus 0.3405 times 0.05. Now to get for Y, 0.3497 times the second column now, 0.03 plus 0.3098 times 0.75, right? Plus 0.3405 times 0.15. Then for Z now, you take 0.3497 times 0.07 plus 0.3098 times 0.115 or 15, sorry. Then plus 0.3405 times 0.80. So let me start with the last one, 0.3497 times 0.07 plus 0.3098 times 0.15 plus 0.3405 times 0.80. How much am I getting here? Right, I'm getting 0.3433. Then 0.3497 times 0.03 plus 0.3098 times 0.75 plus 0.3405 times 0.15. Getting 0.29. Then the first one, 0.3497 times 0.90 plus 0.3098 times 0.10 plus 0.3405 times 0.05. I'm getting 0.3627. Those are the market shares for 2018, at the end of the year 2018. And because the examiner was asking, the question for this examiner was, the question was the market shares. You can see we were able to get all of them there, 0.36, 0.29, and so on. So if we want to convert into to percentage forms, well and good, well and good. Now, let us do the last requirement before I give you an assignment, the long run market shares for the three companies. And when we discuss about a long run, right, we said that the Markov analysis is easy to predict. So how do we normally get it? How do I normally get this? It's very simple. Very simple. How is simple? Remember, we are discussing about a steady equilibrium vector. To get our steady equilibrium vector, we are supposed to be taking steady equilibrium vector we multiply by the transition probability matrix. I know this one is not it is not well understandable. Now, in this scenario, when you look on the initial state, we said that when you look on the an area where the Markov analysis is to predict, we say that if at that stage we continue predicting using the Markov, that is a steady equilibrium state. We said once we continue predicting using the Markov analysis, it will be giving us a similar answer. So my formula will normally look like this. Remember, the first column represents X, Y, and Z, right? So this is your X, this is your Y, this is your Z. Now, in this case, because we want to get the proportions for X and Y, we normally formalize two equations because we are dealing with probabilities. And once we have two probabilities for the first unknowns, right, or for the X and Y, we are going to be subtracting from one and then we get for the value for Z. So how do our equations look like? So it will be x, y, 1 minus x minus y representing z, which should be equal to x, y, 1 minus x minus y times our probability. Our probability is here, right? Transition probability 0.90, 0.10, 0.05, 0.03, 0.75, 0.15, 0.07, 0.15, 0.80. They look like that, right? Now, in this case, we just want to formulate the first equations. I take these values, I multiply with the first column, right? Then it will be 0.90x plus the second one will be 0.1y, right? Then the last one it will be plus, right? 0.05, 1 minus x minus y, which should be equal to the first value, which is your x. Let me open this and I put the like term together before I formulate the second equation. It will be 0.90x plus 0.1y plus 0.05 minus 0, open your brackets here, 0.05x minus 0.05y should be equal to x. So let us put the like sum together, 0.90x, right, minus 0.05x. Then when you bring the other one x from the other side, we get minus x there, plus 0.1y, right, minus 0.05y, which should be equal to this whole number you take on the other side, negative 0.05. How does this look like? So you take your calculator, you do your summations here. Right, let us take our calculator. So it will be 0.90 minus 0.05 minus 1. You are getting negative 0.15x. What about this one? 0.1 minus 0.05, getting positive 0.05y, should be equal to negative 0.05. You denote this as your first equation. Now, when you go to the second one, you take also these values. You multiply with the second column, so it will be 0.03x plus 0.75y, right? Then plus 0.15, 1 minus x minus y. Then you equate to the second value, which is your y. Put the like terms together, 0.03x plus 0.75y plus 0.15 minus 0.15x minus 0.15y should be equal to y. So 0.03x, do we have any other x? Minus 0.15x plus 0.75y minus 0.15y minus y. We're going to be getting negative 0.15. Let us take these x's to the same minus 0.15, getting negative 0.12x. What about y? 0.75 minus 0.15 minus 1, getting negative 0.4 y, which should be equal to negative 0.15. This is my second equation. Let me compile my equations to get the value of unknowns. So it will be negative 0.15x plus 0.05y should be equal to negative 0.05. Then the other one will be negative 0.12x minus 0.4y should be equal to negative 0.15. In this case, we just want to eliminate one unknown. And in this case, I can just be able to multiply the values of x. Let me start with x. Let me eliminate x, sorry. So here I multiply with, can I multiply with negative 0.12? And then here we multiply by negative 0.15. And then you open your brackets. Now in this scenario, we say negative 0.12 times negative 0.15, getting 0.018x, 0.018x plus now, right, plus the other one, it will be 0.05 times negative 0.12, right? How much am I getting here? I'm getting negative here, negative 0.006. Y, we should be equal to negative 0.12 times negative 0.05, getting 0.006. Now, the other one down here, it will be negative 0.15 times negative 0.4. I'm getting positive 0.06. Y, we should be equal to, right, negative 0.15 times negative 0.15. I'm getting 0.0225. Subtract here. So once we subtract, x ends. So you're going to be remaining with negative 0.006 minus 0.06, getting negative 0.066, right? Y, we should be equal to 0.006 minus 0.0225. I'm getting negative 0.0165. You divide here by negative 0.066. You divide here by negative 0.066. So the value for Y should be equal to, you divide here by negative 0.066. I'm getting 0.25. 0.25. Now let me substitute for x, right? I'm just taking those equations of mine there and I substitute for x. Substituting for x here, it will be, right? It will be looking like this. Negative 0.15x plus 0.05. You multiply by the value of y, which is 0.25, right? Should be equal to negative 0.05. Now, 0.05 times my answer, I'm getting 0.0125 plus negative 0.15x is equal to negative 0.05. Take this on the other side. Negative 0.15x, we should be equal to negative 0.05 minus 0.0125, right? So I just say negative 0.05 minus my answer. I'm also going to be getting 0.0625, right? 0.15x. So let's get the value of x. So our x is how much? Our x should be equal to negative 0.15, which you normally get 0.42. You have for x and y. How can we be able to determine for z? We just say, together for z, the market share for z, we take 1 minus x minus y. In this case, it is 1 minus 0.42 minus 0.25. 0.25. So 1 minus 0.42 minus 0.25, getting 0.33. Those are the market shares when you are using the long run vectors. Using the long run vectors. Is it okay?
Yes.
Very good. I just want to give you an assignment. Just go and try December 2017. December 2017, question 1A. Question number 1A. Any other time, because I'll just be able to pop in for another online morning class, I'll be able to do input-output matrices. And once we finalize the matrices, we can combine with set theories as we engage on our third topic of discussion. If we don't have any other question, we can stop at that point so that we can prepare ourselves to go to work. And then we continue with our normal preparations. So I'm expecting to continue with the revisions. So let us up our revisions as we soldier on.
Okay.